Hello there!
In this video tutorial, we'll be talking about how to solve limits of exponential functions. So, what are exponential functions?
Exponential function is a function whose value is a constant raised to the power of the argument, especially the function where the constant is e. There are regular exponentials such as having constants that are numbers and exponentials that have the constant e or the Euler's number, which is called the natural exponential functions.
In this video, we'll be able to learn how to solve the limits with solutions that will lead to the correct answer. Without further ado, let's get on with the tutorial.
First, let's start with the easy round. In this part, we'll be solving the limit of exponential functions that can be evaluated. First step in this process is to identify where x is approaching to in the function given. As we can see, it is approaching to negative infinity. To be able to solve this, you need to be aware of the following generalizations as to solving this type of function. These are the generalizations, and if you look at it, for this function, we're looking at the limit of the function as x approaches to negative infinity. It is stated that if b is greater than 1 as x approaches towards negative infinity, the limit of the exponential function is 0. Just like in the given example, 4 is greater than 1 as x approaches towards negative infinity, which means to say that if we evaluate negative infinity, the limit of 4 to the power of x is 0. After that, we have a 0 minus quantity 1/2 squared, which gives us 0 minus 1/4. We simplify it by subtracting 1/4 from 0, which gives us the limit of negative 1/4. Therefore, the limit of the exponential function 4 to the power of x minus 1/2 squared as x approaches to negative infinity is negative 1/4.
Next, let's go with the average round. We must keep in mind that as we get to answer more complex problems or functions, we should never be fooled by its appearance because these are just a combination of the basics we have learned in our previous lessons. So, we must analyze the problem first before answering them. For the next round, we have the given. What is the limit of the exponential function 8x squared minus 8x squared times e to the power of x all over x cubed as x approaches to 0? Since we see that there is e as a constant, first we need to be aware of the generalizations for natural exponentials. These are the generalizations for exponential functions. As you can see in the problem given, it is 1 minus e to the power of x when it should be e to the power of x minus 1 as the numerator with x as the denominator to evaluate it as 1. So we factor out the negative 1 in the numerator and multiply it to 8x squared, which means that the whole numerator will look like this. Next, we simplify the numerator and denominator through subtracting the exponents of both the numerator and the denominator. Then we have negative 8 times the quantity of e to the power of x minus 1 all over x. Now that we have encountered quantity e to the power of x minus 1 all over x, remember that we must follow what is stated in the generalizations, which means that its evaluation is equal to 1. For the last step, we are now able to simplify it through the multiplication method. Negative 8 times 1 will give us an answer of negative 8. Therefore, the limit of 8x squared minus 8x squared times e to the power of x all over x cubed as x approaches to 0 is equal to negative 8.
For the last round, we will have the most complex one, for it makes you analyze the problem more. The given is, what is the limit of the exponential function 18x squared e to the power of x minus 18x squared minus 7e to the power of x plus 7 all over 36x cubed as x approaches to 0? A hint is that you should be able to factor out a binomial. Please pause the video first so you could try answering this problem. After a few minutes, you may play it so as to see the solution to this answer. So what you do first is that we look at our generalizations again in order to come up with a function e to the power of x minus 1 all over x in order to give its evaluation, which is equal to 1. First, we factor out, which gives us 18x squared times the quantity of e to the power of x minus 1, then subtract to 7 times the quantity of e to the power of x minus 1 all over 36x cubed. Next, as we can see, we can still factor out, which gives us a binomial of quantity 18x squared minus 7 times the quantity of e to the power of x minus 1 all over 36x cubed. Next, after we factor out the binomial, we need to simplify further as to factor out the denominator that would lead us to a generalization in exponential functions. So here we have 1 over 36x squared times the limit of quantity 18x squared minus 7 times the quantity of e to the power of x minus 1 over x. Now, we have 1 over 36x squared times the limit of 18x squared minus 7 times the limit of e to the power of x minus 1 all over x. Now, we can start evaluating. Take note that e to the power of x minus 1 all over x is a generalization that has an evaluation equal to 1. So now, we have 1 over 36 times 0 squared times the quantity of 18 times 0 squared minus 7 times 1, which gives us 0 times negative 7, which is equal to 0. Therefore, the limit of the exponential function 18x squared e to the power of x minus 18 squared minus 7e to the power of x plus 7 all over 36x cubed as x approaches towards 0 is 0. Now that you have fully understood the process of finding the limit of exponential functions, you can try other exercises so as to increase your knowledge on this lesson. Never forget to always analyze and understand what is being asked first before you answer for the best results. Till next time, everyone. Bye-bye.